The history of engineering in America starts with just history itself. European settlers coming to America and gaining independence is what both spurred great advancements in engineering as well as created many difficulties. Americans took influence from the differing views of the French and British engineers. The French believed in learning the theory behind engineering, while the British simply believed in designing whatever worked. When Americans first started engineering, they often followed the British tradition. One of the things Americans found most important to build were canals. The Middlesex Canal was one of the first canals built, and it ended it with many more failures than successes. Without people to pass on knowledge, the people working on the canal had to figure things out for themselves. After this, some Americans believed the Erie Canal could solve a lot of issues, allowing for cheaper transportation of goods. One of these people was DeWitt Clinton, who wrote a letter to explain the huge benefits the canal would bring. The canal was seen as the first engineering school. Many of the engineers who worked on the canal became engineers by learning while building the canal. They struggled to do things we may see as simple now, such as preventing leaks and designing locks for the canal. However, they had much greater success than those who worked on the Middlesex Canal. People began passing on knowledge to others, rather than each person having to learn from scratch. Many workers also took the job more seriously, which meant less preventable mistakes. After the Erie Canal, there were many more advancements in engineering. However, these advancements benefited some more than others. Technological advancement that replaced another device could put many out of business, while making the inventor of the new device very wealthy. In the years following the Erie Canal, engineering just advanced further and further with the introduction of engineering societies and schools.
Okay, moving on to Module 2, we have engineering becomes a profession. I'd like to touch upon a few subjects here, such as how the rise of industry led to America's need for more engineers. And with the new demand for engineers, the need to educate these engineers becomes a priority. Also, how more and more of these engineers in the corporate setting led to the rise of professional societies. Okay, just to set the scene here, we're talking 1850 to the early 1900s, America post-Civil War. The population has risen to over 75 million. Manufacturing is really taking over, but farming still consists of about 60% of the economy. And with advances in railroads and other transportation technologies, Americans are living coast to coast now. The Gilded Age took place here in the late 19th century, where basically a few men got super rich while workers had to work long hours in unsafe conditions. And finally, the Progressive Era of 1895 to 1918 gave rise to people wanting experts in charge to solve common social problems. In 1850, the U.S. trailed Great Britain, Germany, and France in production, but by 1900, the U.S. outpaced all three countries combined. This great industrialization led to corporate growth, which led to the demand for highly trained engineers. And here's just an example of a large copper mine where highly skilled engineers might have worked. Here's a few examples of engineers at work in the late 19th to early 20th century. We have civil engineers with their surveying equipment, chemical engineers at MIT, and engineers hard at work in the Bell Labs. The need for engineers led to an increase in educational institutions. The Morrill Land Grant Act of 1862 was pivotal to meeting the educational needs of the country. The act provided federal lands to build universities, and it opened opportunities to thousands of farmers and working people to higher education. By 1900, there were over 100 programs for training engineers. Students training for engineering went from 100 to 1890 to 10,000 in 1900. 70% of engineers trained at land-grant colleges. Here we see the Erie Canal, often called America's first school of engineering. West Point, one of America's first institutions for training engineers. And lastly, we have a picture of Justin Smith Morrill. Here we have engineering shifted from independent consulting jobs to a more corporate setting where advanced manufacturing enterprises needed highly trained engineers to turn a profit. Thus, engineers struggled with autonomy in that they wanted more freedom to tell the bosses what they needed to do. This gave rise to professional societies that gave engineers an avenue to increase professionalism and status of their different engineering fields. The main objective of professional societies are to strike a balance between business and professionalism, develop ethical codes, and establish training and educational requirements. The four founder societies included the American Society of Civil Engineers, the American Institute of Mining Engineers, the American Society of Mechanical Engineers, and the American Institute of Electrical Engineers. The ASCE had very strict membership criteria to advance their professionalism, while the AIME leaned more towards industry, letting almost anyone involved in mining gain membership. The ASME and the AIEE sought a balance between professionalism and friendliness to business.
The types of inventions vary greatly, like Joseph Whitworth's improvements to screw threads and James Watt's improvements to Thomas Newcomen's original steam engine, to very radical inventions like Edison's light bulb, Alexander Graham Bell's telephone, and the Wright brothers' airplane. When it comes to the independent inventors, all of them worked with small teams of assistants and converged the scientific approach with an empirical trial and error approach. Some were professionals and raised money to create their inventions, like Thomas Edison, while others invented on their spare time while working an outside job, just like the Wright brothers. Thomas Edison built Menlo Park in 1878 to escape the mayhem of New York City and Philadelphia. Beginning with 15 muckers to assist him, he was able to focus on his inventions, where Edison created a method of invention that expanded into the General Electric Company, which employed thousands in Schenectady, New York. This would lead to the rise of the industrial research labs, which have large staffs, but less acclaim for the individual engineer. Also, funding is there for research and development departments. Two famous examples are Westinghouse Electric Corporation and Bell Laboratories. This concludes our presentation on the rise of early American engineering up to the formation of the Industrial Research Lab.